Angular momentum and its conservation. What is momentum? Momentum is the product of mass and velocity. P equals to m times v, where P equals to momentum, m equals to mass, v equals to velocity. Every moving object will have its own momentum. Bigger the object, larger the momentum it produces. What is angular momentum? Angular momentum is a product of moment of inertia and angular velocity. L equals to I times omega, where I equals to moment of inertia and omega equals to angular velocity. Relationship between momentum and angular momentum. Examples of angular momentum: fidget spinner, Earth orbiting the Sun, and even a Ferris wheel. Conservation of momentum. If no net torque or force acts on a system, angular momentum is conserved. For an example, when the moment of inertia decrease, the angular velocity increase, or when the moment of inertia increase, the angular velocity decrease. But these changes will not affect the value of angular momentum as there is no net force added into system.
So please observe what happens when the boy brings his hand close together and widen his hands while spinning. This video will prove how angular velocity and moment of inertia influence the system. From this video, we observe that the angular velocity increases when the boy brings his hands close together, and the angular velocity decreases when the boy widens his hands. Let's watch the video again. For example, let's say in the previous video, the angular momentum is equal to 25 kg meter square per second, which is a product of 5 kg meter square times 5 radians per second. When the boy brings his hands together, the radius will decrease, causing the moment of inertia to decrease from 5 kg meter square to 4 kg meter square. But how these changes will affect the momentum and angular velocity? The angular momentum remains constant, but the angular velocity will increase from 5 radians per second to 6.25 radians per second so that it can achieve the same angular momentum. We can conclude that changes in moment of inertia and angular velocity will not affect the angular momentum because it is conserved.
Bob and Marley are on merry-go-round moving with a constant velocity, but Bob is spinning with a radial length of 5 meter and Mali is spinning with radial length of 7.5 meter. If both are having same mass, who is having a larger momentum?
It is Mali because he has a longer radius producing a bigger angular momentum. When radius increases, moment of inertia also increases. When moment of inertia increases, angular momentum increases.
What is the effect on the girl's angular velocity if she spread her hands?
In this case, angular momentum is conserved. So when she spread her hands, her radius will increase, causing the moment of inertia to increase too. When moment of inertia increases, the angular velocity will decrease so that it can conserve the angular momentum.
Summary. Momentum is a product of mass and velocity. When the mass increases, the momentum also increases. Angular momentum is a product of moment of inertia and angular velocity. When the moment of inertia increases, the angular velocity decreases and vice versa. The momentum is conserved if there is no net torque or force acting on the system. For an example, when moment of inertia increase, the angular velocity will decrease, but these changes does not affect the momentum because it is conserved. Now everyone can physics. Thank you.